Welcome to a brand new unit. We just finished lessons, what was it, 11 through 19 or something like that, unit 1, which was getting us used to formulas, plugging into formulas, using our calculators, our nifty calculators, being able to write numbers with appropriate levels of precision, sig figs and all that stuff, engineering notation, all that stuff. Okay, cool. Now we're going to get into some kind of hefty electrical work, something called Kirchhoff's laws in Unit 2. It's going to be the most algebraic part of the course by far. We have to do some serious algebra in this unit. And so we're going to start right at the beginning with solving equations for x. And I mean just basic equations, linear equations, nothing too fancy. X isn't going to be squared or anything weird like that. So just solving some nice equations for x. Now, in order to get to our 4-point plan, I have a 4-point plan, or I should say a 4-step procedure that'll always work for us. What we should do is we should learn what some of those steps are. So I've got a few building blocks on page 1. And so our first building block is we all need to know how to distribute, which is another word for removing parentheses. So I have 6 examples here. Now just take a look at this for a second and just ask yourself what that equals if you were to work it out. Remember something about do what's in parentheses first, and so 12 minus 5 is 7, and so we've got 2 times 7 is 14. Okay, that really is the answer. 2 parentheses 12 minus 5 comes out to 14. But I want to show you something different. I want to show you something called distributing. Distributing is where you go like this. See that 2? Now, when you have a number right up against a parentheses, it's understood that we're multiplying. And the 2 is multiplying what? Everybody. Everybody that's in the parentheses. And so I multiply the 2 times the 12, which is 24. And then I multiply 2 times, and you could think of this as minus 5, or you could think of this as minus 2 times 5. Anyway, that's 10. And then 24 minus 10, isn't that what we got before? Yeah, it is. We got 14. So I'm just showing you that distributing is another approach you could take. The direct approach got us 2 times 7 is 14. And then this is the distributing approach. Okay, so why would you want to do the distributing approach instead of the direct approach? Well, the only reason to do the distributing approach is if you have like x's in there. So it's like you literally cannot do what's in the parentheses, x minus 3, because you don't know what x is. But you would like to make some kind of headway. Well, you can make headway by using that distributing idea. So you say this equals 2 times x, and then you've got the minus 2 times 3 is 6. And you've just distributed. So that's what it's all about. Let's look at this one. So you'll notice that this example and this example are fairly similar. Let's do this one the direct approach again. So maybe I'll call it the direct approach, dA. You'd have a negative 3 multiplying, again, 3 up against parentheses means multiplying, and you'd want to finish what's in the parentheses if you could, and we can. 5 plus 2 is 7. So negative 3 times 7 gives us a negative 21. That's the direct approach. Distributing, you would go like this. Negative 3 times 5 is a negative 15. And make sure you're taking negative 3 with you. Negative 3 times a positive 2 is a negative 6. And notice when you take a negative 15 and subtract 6, you do indeed get a negative 21. Okay, so I'm just showing you how this works. This negative 3 has to multiply the 5. This negative 3 has to multiply the plus 2. Down here, this negative 3 has to multiply the x. And some people miss this. Be careful. This negative 3 has to multiply the positive 2 to give us a minus 6. Okay. This is the distributing game. Again, it's necessary to play this game if you've got x's in your parentheses. Oh, one more set, just to try to knock this point home. So ask yourself, if I did this using the direct approach, what would I get? Well, direct approach means, well, that negative out front, by the way, you can think of this as a negative 1. Okay, it's a negative multiplying the parentheses, which makes more sense if you say it's a negative 1 multiplying the parentheses. So because it's right up against the parentheses, there's no space, it's a multiplication. Minus 1 times 7 minus 10. So the direct approach would be I have a minus 1 times. Now 7 minus 10 in the parentheses becomes a negative 3 in the parentheses. And then when you multiply negative 1 times negative 3, you get positive 3. Let's do distributing instead. Make sure we get the right answer. We sure should. So distribute what exactly? Well, I'm distributing the negative 1. The negative 1 times the 7 gives me a negative 7. And then the negative 1 times the negative 10 gives me a positive 10. Negative 7 plus 10 is indeed a positive 3. So this is the thing I'm trying to point out here. This negative has to come in and multiply, just as though it were a negative 1. It has to distribute inside to make that a negative 7 here, and to make that a negative times a negative is a positive 10 here. Okay, even a negative in front will distribute. I should probably say, let's kind of stick this over here somewhere. If you had something like 5 minus parentheses like this, 7 minus 10, well, you would still think of this as a negative 1 distributing into, just like that, even if it looked like there was a little bit of a space between the minus and the parentheses, is what I'm saying. The minus is followed by a parentheses means that minus is distributed into the parentheses. Again, it's a minus 1 really, distributing into the parentheses. So what does this become then? Ask yourself and then answer yourself. Negative 1 times x is a negative x. Negative 1 times negative 2 is a positive 2. So that's what that looks like when you distribute. Okay. I'm pretty sure that if you got all these examples and you're happy with them, that you'll be distributing pretty well. Just be careful with negatives. Sometimes it's easy to mess up a negative. I do it myself sometimes, even still. So be careful with the negatives. So that was thing 1. Thing 2, this is another little thing we have to learn about before we can solve our equations. We have to learn something called, I'll use a different color, combining like terms. And it says right here, if you have like terms, you can add them together. If they're not like terms, you can't. What are like terms? Well, these are like terms. Why? Because they're both x terms. Both are x terms. That means we can add them together. And you do that by adding the 2 and the 5. 2x plus 5x is 7x. And that's all there is to it. They're like terms. They're both x terms. Just add them up. 2x, 5x, 7x. Over here, are these like terms? The 12 and the 17 minus the 17? Yeah, those are both, we call them constant terms. Often you'll hear me just say number terms. But they're both the same. Neither one of them has an x in it, so they're both the same. And that means you can add them up. So you're adding up the 12 with the negative 17, or if you prefer 12 minus 17, either way you look at it, you get a negative 5. Those are like terms. Now this one, be careful. I've seen people do this a lot. No. These are not like terms. One's an x term, one is not. And if they're not like terms, you'll leave them alone. Leave them be. You do not combine them. Do not combine. Maybe I'll put it that way. Do not add together. Do not combine. They're not like terms. You can't do it. Don't do it. 3x plus 2, don't do it. They're not like terms. So let's come down and do some slightly bigger examples. So looking at this one here, we've got, well, you have to say, well, we got 3 terms here. Terms are separated by adding and subtracting. So you get a term, a term, a term. We got 3 terms here. And then what you want to do is you want to ask yourself which ones are like each other. That's an x term. That's an x term. Those go together. The 8 is not an x term. It does not combine with the x terms. It stays separate from the x terms. But these 2 x terms, and notice how I underlined them. That's a negative 3x, and count the symbol in front as part of the x term. That's a positive 4x. So a negative 3x plus a 4x is a positive 1x. Or if you want, you can just say x. Positive 1x and x are just the same thing. And then don't forget, you got a little 8 schlepping along. wrong. So it's x plus 8. Now this one is sort of a trying to catch every possible example at once kind of example. Notice I've got positive, positive, minus a positive, plus a negative, minus a negative. I got every possible combination here. So what are we going to do? The first thing I'm going to do is I'm going to, well, I want to get rid of the parentheses, really. So we're in the like terms idea, and you notice I've got an x term here, and I've got an x term there. Those have to go together somehow. These are all constants, or number terms. Those have to go together somehow. But I'm not really ready to add them yet. What I'd like to do is actually get rid of my parentheses. So this is a negative 12x. That's normal. That's fine. Plus a plus, really that just means plus 4. That's all it means. Plus a plus. If you add a positive number, you're adding. Minus a plus, that's the same as subtracting 5. Adding a negative, that's the same as subtracting 6. And then subtracting a negative is the same thing as adding a 7x. So notice that what I did there follows the old, if you have two pluses and you multiply them, you get a plus, and if you have two minuses and you multiply them, you get a plus. But if you have a plus times a minus, or if you have a minus times a plus, it comes out negative. This is the rule for multiply and divide signs, numbers, is that if you multiply two numbers that have the same sign, whether they're both positive or they're both negative, doesn't matter. If they have the same sign, you get a positive answer. But if you're multiplying two numbers with different signs, you get a negative answer. That's exactly what's going on here. Plus plus, same sign, I got a plus. Minus plus, different signs, I got a minus. Plus minus, different signs, I got a minus. Minus minus, same signs, I got a plus. Now what do? I go like this. Try to get some of the smudges out. Okay, so that's what I did. Of course, we need to finish this problem by, now we got to actually combine like terms. So let's take the two x terms. There's a negative 12x, there's a positive 7x. You put those together. You basically add up negative 12 plus 7 is a negative 5x. And then you take all these numbers terms. So it's got a plus 4, take away 5, take away 6. Plus, okay, so start with 4. You take away 5, it's a negative 1. Take away 6 more, it's a negative 7. And again, these do not combine because one's an x term, one's a constant. They don't go together. So negative 5x minus 7. Okay, that's our second building block for solving equations. One to go. So distributing, getting rid of parentheses, you got to know how to do that. Combining like terms, you got to be able to recognize like terms. You got to be able to play around with the plus, minus, minus, plus, all the doubled up sign type. What I just do too. The third building block, and then we'll be ready to actually solve some stuff. The third building block is what I call Teeter-Totter Theory. And actually, we are going to be solving some little equations here, but these are just little equations. These are not big equations. But I want to show you how to solve this with Teeter-Totter Theory. Teeter-Totter Theory says that when you have an equation, by the way, it's an equation because it has two sides. One side is x plus 5, the other side is 8. There are two sides, and they're connected with equals. And that's telling you that if you put this stuff on a teeter-totter, they would exactly balance. What have I got on this side? I got 8. I can represent that with 8 little pound weights or something. What have I got on this side? I got an x and a 5. So the x is like a bag that we don't know what's in it. So we have to label it x. We don't know what it weighs. But the 5, well, you can think about 5 little pound weights, right? I suppose a teeter-totter isn't quite what we'd want. It'd be better to have actual scales, the actual scales where you have the balance, and, that would work a little more accurately. Because the problem with the teeter-totter, of course, is if I put these 8 out here, it's going to go clunk, right? So ignoring that, just assume this was scales actually instead of teeter-totter. Anywho, I'm trying to figure out what x is. That's what I'm trying to do. What's this? Well, if we're in balance now, notice I got like 5 things here. And if I wanted to weigh the x, I would just put the x on that side. I wouldn't put 5 things on that side. So what you want to do is you want to get rid of them, dump them. But if you do that, it's not going to be balanced unless you do the same thing over here. Take 5 off and dump them. And then you'll be able to see, oh, so x is the same as having 3 of those pound weights. X must be 3. That's the Teeter-Totter theory. Now the math move that we usually use is we go like this. You got x plus 5 equals 8. Think of this as the fulcrum or whatever you call that. And you say, here's my x. That's my prize. That's what I want to solve for. I don't want 5 added on. So I'm going to subtract 5 on both sides of my equation. And then you look at this side of the equation and you say, what have I got? I've got x plus 5 minus 5. Well, the plus 5 minus 5 cancel each other, so it's just x. And then on this side of my equation, what have I got? I got 8 take away 5. Well, that's a 3. And so you get the right answer. Okay? So that justifies it. You can always subtract or add, it turns out, on both sides of the equation. This one's kind of similar. I'm going to use an actual balance this time. Something like this, so it looks like an actual balance. So over here I got not 1x, but 2x. That's kind of like saying I have 2 of these bags. Right? I got 2 of these mystery sacks or whatever. Over here I've got 8 of these pound weights. Okay, and that's in balance. So ask yourself, if I wanted to measure the weight of one of these X bags and I wanted to use a scale, I wouldn't put 2 of them. I'd just put 1 of them. So I've got twice what I want over here. What I got to do, I got to take the left side and kind of take half of it and throw half of it away. So let's throw this half away. Now if I'm throwing off half of one side, then I should throw off half of the other side. And you can say, oh, well, if I get rid of half of the right side, I'll have 4 left, and so x must be equal to 4. And that is indeed true. Now I'll show you the math class way of doing it. You take your equation, 2x equals 8, and in this situation, by the way, notice it's not the same as this situation where we added 5 to the x, and since we added 5, we had to subtract 5. Here we're not adding 2. We're multiplying by 2. And what's the opposite of multiplying by 2? The opposite of multiplying by 2 is to divide by 2, which is exactly what we did here, right? We cut it in half, which means divide by 2. So in this situation, what you're trying to do is you're trying to divide the 2 off. You're trying to cancel it off. Divide by x's coefficient to cancel it off. Okay, here you are subtracting on both sides. But here, we're dividing by x's coefficient on both sides. And notice what it leaves you. 8 divided by 2 is indeed 4. And so you get the right answer. Cool. And those are your 2 main moves. There's the old add or subtract on both sides, and you would apply that in a situation that looks like this. And there's the old divide both sides, and you would apply that in a situation that looks like this. Okay, so keep these 2 things separate. So over here, what you'll notice is we've got 2 things to do. Because I got to get rid of this 2 and I got to get rid of this 6, right? I want to have just x all by itself here. So on the teeter-totter, let me do one more teeter-totter. Come on, man. Come on, man. Just oblige me. Just, what's the word? Humor me. Just humor me. Another teeter-totter. So this side has 8 loose pound weights. This side has not just 1x, but 2 of them. And then 6 pound weights. Okay, that's our balance. The question is, well, what does one of these x's weigh? So we have to start by getting rid of some stuff. Now notice over here, I'm not ready to cut, well, Maybe I am ready to cut that in half. But if I did cut it in half, I'd have to do it very carefully. I'd have to take half of the x's out, and I'd have to take half of these pound weights out. And that sounds complicated to me, so let's not do it that way. Let's just agree that first we're going to throw away these loose weights. First, subtract 6. So I'm throwing away 6 weights. First, subtract 6. Then, what I'm left with is a pair of x's. I would like to throw half away. If I throw half of these away, that x will be gone. And if I throw half of these away, well, one of those will be gone. And notice I'm left with an x on the left. I'm left with a 1 on the front, on the right. Now, if you don't always want to drop pictures, that's fine. What you can do is you can say, okay, so what I did first was I subtracted 6 on both sides. So that left me with the 2x here. 8 take away 6 is 2. And then I divided off the coefficient. And I got 2 divided by 2 is just 1. So that's x equals, and well, 2 by 2 is 1. And I got 1, which is the right answer. Okay. So if you have both moves to do, you've got some subtracting and some dividing, my tip is to first subtract the 6, then throw half away. Subtract first, or sometimes you add or subtract first, then worry about the x's coefficient. What you would not want to do, and maybe I'll just put this here for emphasis. So let's kind of sneak this up here, PS. If you had 2x plus 6 equals 8, here's the most common mistake in the world. Someone will say, well, I'll cancel 2 left and right, and I've got x plus 6 equals 4. And then the problem is you subtract 6 on both sides, and you're getting x equals negative 2, and that's not the right answer. Okay, and it goes back to when I was starting to cut it in half, and I said, well, if I'm going to throw half away, I have to throw away half the x's and half of the 6. I would have to divide that by 3 as well, or by 2 as well, and that would give me an x plus a 3 equals 4. And when I subtract 3, I would get the right answer. Okay, so if you just want to, if you don't want to worry about this fine detail, just always save your dividing for last. Which is what I'm going to do on the next page. So on the next page, we've got a 4-step plan of attack that you can use for all of these equations, and I've got 4 examples of them. So 4-step plan of attack. What are our 4 steps? First step is if you have parentheses, you should distribute. And we took a look at how to distribute. Second thing you should do is combine like terms on each side. And that's why we looked at combining like terms. The next thing you do is teeter-totter stuff. Adding and subtracting. Leave the dividing for last. Step 4 is going to be the divide. Okay, step 4 is the dividing. But step 3 is going to be the old add and subtract on both sides until you're left with a single x term on one side and a single number term on the other. Okay, so those are our basic steps. So let's put these into action here. So here's a problem that, yes, I'm going to solve it twice. Okay, do we need to get rid of any parentheses? No, there's no parentheses. Do we need to combine like terms? Now, it's saying on each side. When you combine like terms, you have to stay on your side, right? So I'm looking at this side, and I'm saying not like terms. Then I look at this side, and I say not like terms, which means I do not have to combine any like terms. Okay, this is very important. Stay on your side when you're combining like terms, okay? Step 3, add or subtract like a teeter-totter. So what I'm going to do here, you see that? See, there's the x. I like the x. You see that 4? I don't like the 4. I don't like the 4. I don't want the 4 there. So I'm going to subtract 4 on both sides. And what does that leave me with? Notice I'm keeping the sides separate. Well, the 7x, the plus 4 and minus 4 go away. So I'm just got a 7x. And on this side, I got a 12x. And then the minus 1 minus 4 will make a minus 5. Okay, so that got me here. Well, that's a little better. except I don't really want to have, I've got my x over here. I don't want to have another x on the other side. So what I got to do here, since that's basically adding 12x on, it's positive in front, so we're adding 12x, I have to do the opposite, which is to subtract 12x. Subtract 12x. Again, keep your sides separate. So here I got a 7 take away a 12, gives me a negative 5x. And over here, well, the 12x minus 12 goes away, but I'll still have that minus 5. So negative 5x equals negative 5. That was step 3, and then last step, divide both sides by the coefficient. So I'm dividing by negative 5. Yes, I divide by the negative and everything. I want the 5 to cancel. I want the negative to cancel. And it looks like negative 5 over negative 5 is just 1. X is just equal to 1. So I did it that way. I'm going to do it one more time, because sometimes what people do is, you see that 12x? It's like they're thinking, if I subtract 12x on both sides, I'm going to have a negative 5x over here, and I don't want to deal with it. I don't want to deal with it. So you don't have to get x to the left. If you want, you can get x to the right. And so let's say we did that first. First, we subtracted 7x on both sides. So 7x, oops. So 7x minus 7x goes away, but plus 4. So the left side is now just a 4. And then on the right side, 12x take away 7x is 5x with a minus 1. 5x with a minus 1. And then you look at this equation and you say, okay, my x is over here. That's a good place for it. I like it there. So what I don't want is I don't want this plus 1, or this minus 1 there. So I'm going to have to add 1. Again, keep your sides separate. Keep your sides separate. I'm adding 1 on both sides. So 4 plus 1 is a 5 over here. And then you get the 5x over here. And then the minus 1 plus 1 cancels. And then finally, this is the 5 I'm looking at because I'm trying to get x by itself. I'm looking at that 5, and I'm dividing both sides by that 5. That 5 cancels off. X equals 5 over 5 is 1. It's the same answer. So notice there's a little bit of leeway. Some people, like I usually just get x to the left no matter what. But if you really don't like having negative x on your left side, well, if you notice there's more x's on the right, you might want to put all your x terms on the right. Whatever. I just mentioned both because, well, it's nice to have options, right? All right. Let's try this one now. New color. Okay. Oh, this one's bigger. Step 1. Do we have any parentheses? No, we don't have any parentheses. We don't even have to do step 1. Well, that's cool. Step 2. On each side, which means I look over here and then I look over here. Look at each side separately. Combine like terms. So on the left side, you'll notice that the 8 and the 2 are both numbers. They go together. 8 plus 2 is 10. And then don't forget your minus 3x. On the right side, I have a couple of x terms. I have a 2x minus a 5x. Gives me a minus a 3x. And then don't forget your plus 11. Okay. So that's what's meant by on each side separately, combine the terms together. Okay. You're not combining like, you're not combining this 2 with this 11 or something like that because they're on opposite sides of the equation. Do not combine this 2 and this 11 together. It's not a good idea. They're on different sides. You can't do it. It's not legal. It's not even a good idea. It's not even legal. Okay, so now we're at this spot. Uh-oh. Ha! Well, this is a bummer. If this ever happens to you, watch what I'm going to do. I wasn't even expecting this, but watch what's going to happen here. I see that I have negative 3x on both sides. So I'm thinking, okay, keeping my sides separate, I would like to add 3x on both sides. Foink. On the left side, we get 10 minus 3x plus 3x. It's just 10. Then on the right side, we got minus 3x plus 3x plus 11. So it's just 11. Whoa, where'd x go? There's no x anymore. Well, if there's no x anymore, you cannot solve. There is no solution to this one. Oh well, that does happen in life, so you might as well come across it once, right? Gee whiz. 10 equals 11 obviously is not true. So if it's obviously not true, then the equation obviously is never true. There's no x you can use that will ever work, because you've got the same kind. You've got negative 3x here, you got negative 3x here. It doesn't matter what x is. It's going to be the same on both sides. There's no solution. You cannot solve for x. Well, let's hope we don't get that unlucky on this one. This one's a little more complicated. We got parentheses. So we're going to do the parentheses first. This is where the distributing goes. 4 times 2x is 8x. 4 times a minus 3 is a minus 12. Equals. Here I've got 20. Just slip it down for now. And remember that this minus in front does have to distribute. That becomes minus x. And this becomes minus times positive is minus 1, like this. Maybe you can think of this as a minus 1 in front. So the minus 1 times the plus 1 gives you the minus 1. That's my distributing. Combining like terms. Well, on this side, those are not like terms. They just stay separate. But on this side, you'll notice I have two numbers that can go together. So 20 take away 1 is a 19 minus an x. Here, I think what I'm going to do is I'm going to add x to both sides, because I want my x's to be only on the left, not on the right. So keeping my sides separate again, I'll have a 9x minus a 12. Here I'll have a 19, and the minus x plus x will cancel each other. Now, I like the 9x there. What I don't like is the minus a 12, so I'm going to do the opposite. I'm going to plus a 12, keeping my sides separate. So now the left side becomes a 9x. Minus 12 plus 12 goes away. And the right side is 19 plus 12 is 31. Let me bring this up over here because we're running out of room. 9x equals 31. Now it's time for our last step, which is, this is where you find your x. Is my x on the right or on the left? It makes a big difference. Since my x is over here, it's the 9 that I have to get rid of. It's the 9 that I have to divide by. I have to put a 9 underneath both sides. So 31 divided by 9. Good thing you got a calculator, huh? 31 divided by 9 is, hit my SD button and all that, it's a 3.4 repeating. So if we use at least 3 sig figs, 3.44 seems like a good answer. One more example. This is one of those, if you can do this one, you can pat yourself on the back and get at the homework with an eager face. It's bigger numbers, but that's okay. You've got a calculator, right? You can multiply and add and subtract all these numbers with a calculator. Not a problem. It's mostly, you've got parentheses, you've got like terms, you've got it all. So yeah, why don't you just try that one? Having tried that one, now you're eager to see my solution. So let's get at it. So the first thing I have to do, here's a distributing situation. I have to multiply the 2.735 times the 1.14. And actually, I'm going to first take my calculator out of scientific notation, because I don't want to limit myself to 3 sig figs. For one thing, that's 4 sig figs. I don't want to limit myself, not in these problems, I don't. So I'm going to first do that. Shift, setup, or I should say shift, setup, and then an 8 for normal, and then a 1 for normal type 1. Then I say 2.735 times 1.14 equals, this is a 3.1179x. Now I multiply this times this. Notice it's a plus times a minus. It's going to be a minus. What have I got? 2.735 times 0.89 equals 2.43415. And I'm just going to carry all my digits for now because I'm trying to maintain an accurate answer. Then I've got this minus x. Then I go to the other side where I've got a 5.214. And then I've got another parentheses. So I'm distributing again. Minus times the 3.151 is minus 3.151. And then minus times the minus makes a plus to x. So that was my first step. I got rid of my parentheses. Next step, combine like terms. And again, stay on your sides when you're combining like terms. I have an x term. I have an x term. This is like a negative 1x, right? So I got a 3.1179x, take away an x, is a 2.1179x. And then this number is just there by itself, so minus 2.43415. So I've simplified my left side. Now I simplify my right side. These are both numbers. They're both constant terms. I can just subtract those right now. 5.214 minus 3.151 is 2.063. And then I've got my plus 2x. Don't lose any terms, right? You got to keep this all together. Now I think I'm going to maybe like kind of sort of subtract 2x on both sides, because we're going to want x on one side of the equation, not both. So if I subtract the 2x on both sides, this is 2.1179 minus 2, which is 0.1179x. I still got this here, 2.43415 is being subtracted. Over here, I've still got the 2.063, but the minus 2x and the plus 2x are canceling. Cool. Now what? Well, now I've got the x term here, but I don't want this number there. So since that's being subtracted, it's a whole term being subtracted, I need to add that on both sides. Now what have I got? I got a 0.1179x on the left. These are canceling. And then here I got to add those two things up. So plus 2.43415 is, I got a 4.49715. Whew, okay. And now we're just about there, folks. There's the x. You want to cancel off the x, right? This is what you want to go away. That way you have just an x over here. So make sure you enter this on the calculator correctly. A lot of times people, they'll actually type the 4.49715 first, and then they'll say, oh, divide by the 0.1179, and that's not what you want to do. No, you want to enter the 4. That is what you want to do. Dang it, that's so what you want to do. What people often will do wrong is they'll do it this way. That's wrong. Okay, just make sure you get this. 4.49715 on top, divided by the 0.1179, x, and then I hit the SD button. X is, and if I use, you know what, I'm going to use 4 sig figs. Why 4? Because I see 4, I see 4, I see 4. Well, that one's only 2. But let's assume it was 4. Okay, I'll just say it's about 38.14. I'm not going to get too upset about sig figs in this particular unit. Just carry a reasonable